this podcast, Michael Tamir, head of data science at Uber ATG, talks about building an AI team. So stay tuned. Welcome everyone to Future of Data podcast. Today we have with us Michael Tamir. Mike serves as head of data science at Uber ATG, UC Berkeley Data Science faculty, and head of Phronesis ML Labs. He has led teams of data scientists in the Bay Area as chief data scientist for InterTrust and Takt, director of data science for MetaScale at that's a Sears, and CSO for Galvanize, where he founded the galvanizeU, so University-UNH accredited Master of Science in Data Science degree, and oversaw the company's transformation from co-working space to data science organization. Mike's most recent passion in research has involved applying machine learning techniques to help combat fake news through fakerfact.org project. So Mike, welcome to the podcast.
Thank you, Vishal.
So why don't we start with your journey? Like, what brought you to here? If you can just walk us through your background and what brought you to AI.
Yeah, my background would suggest that I got here by accident. For graduate school, I did a multidisciplinary degree, philosophy of physics, in particular mathematical physics. I spent time in the math department and the physics department, but was paid by philosophers. This is, I guess, evidence you can get a good job if you get a philosophy degree. When I was coming out, graduating, I had done a lot of work in simulation and in learning to code and using machine learning in order to execute on some of the research that I was doing, and so I ended up getting connected with people that needed what now would be called data science skills, and was invited eventually to the Bay Area for MetaScale.
Interesting. And let's talk about your current role. So what do you do now?
Yeah. So currently I oversee the data science teams at Uber ATG. So that's the part of Uber that does the self-driving. I'm also faculty for the MSDS program for the School of Information at Berkeley. So we teach my course is machine learning at scale, how to do distributed machine learning primarily in Spark nowadays. And I also have a research lab, Phronesis ML.
Interesting. So let's talk about the state of AI. So if from your vantage point, whatever you are seeing from other industries, what do you think businesses get wrong about AI, or what do you think that businesses should need to know about AI?
What do businesses get wrong with AI? And this is the name has changed over the years. The ultimate practice has, while it's evolved and technology has gotten better, has been basically the same. First businesses are taking a lot of advantage in monetizing big data, and then they're taking a lot of advantage in monetizing data science. The latest hashtag has been more AI, artificial intelligence. I don't really think that the core purpose of the job working with this, enabling a business to monetize their data through automation and machine learning has changed, though the topic hashtag has changed. Something else that's changed and has changed for the better over the last couple of years are really two pieces. Number one, the distributed scalable machine learning tools that are out there have gotten better and better. Hadoop was replaced by Spark for a lot of the in-memory and computational and ETL jobs. We're doing large-scale distributed ML is most best executed in Spark now. And Hadoop has kind of taken the back seat mostly for storage and retrieval type tasks. And most importantly is the rise of deep learning for industry. When I first started, if I said let's build a neural net, I would be told that hey, go back to academia and research something. Now, if I'm not at least considering deep learning solutions as part of the overall algorithmic approach to solving problems, I'm probably not doing my job.
Interesting. And I think one thing that was really jumped out in your background was that you have experience in managing teams in data science space, and then we are seeing constantly emergence of data science team in this business verticals. So from your vantage point, how much do you think if I'm running a data science team, I should focus on machine learning and AI as a solution? Like what should be my maturity, or when I think okay, I should consider getting into AI and how it could impact the business?
Every organization is different, and so while there are many ways to go wrong, there are also many ways to go right. In general, a couple principles that are important. I would hire team members that are not going to be just working on prototypes. Working close to production code is one of the key steps to, you asked earlier, what can go wrong with AI, and that's one of the things that can go wrong. Also, having a diversity of skills. Often you need quite a bit of data engineering skills. If you're a startup, hiring the data engineers early on as a chief data scientist and keeping that vision, but having the data engineering work come into play before maybe you do some of the more advanced algorithms is often a better strategy than hiring a bunch of data scientists without having the data extraction capabilities. Obviously, having people who are adept at both of those skill sets is fantastic, but sometimes that's hard to do. Something else that I think is just on the topic of what can go wrong in when you do get to the point of you've got your data available, you've got a potential monetization strategy or use case for where machine learning really could be effective. What I've seen, either advising companies, working with several startups, there is a point where you can lose your nerve when you're building a machine learning product. And what I mean by that is, time and again, you hear in conferences of people who invested all this money in AI researchers or data scientists, and then they won't get see the value. And often what happens there is that you're not prepared for the fact that the first time you build it, it's probably not going to work so well. Right? Whenever I talk to students or I talk to researchers in my lab, or we have coaching a new data scientist, a new machine learning engineer, when we do that first prototype, when we build that first application, I have to give my little pep talk that, hey, be prepared that it's not going to work the way we want. The real value of a quality data scientist, a machine learning engineer, is going to be in not picking the right algorithm for the first shot, or even good coding for that prototype, but being able to really understand what it is they're trying to do, how it can break, and the dynamics of where that is, what's going on underneath, not just calling scikit-learn libraries or ML lib libraries. And then being able to adapt and adjust and learn from the experimental process as you build, as you find the right algorithmic fit for whatever the problem you have is.
Interesting. And I think I remember that couple of years back when data science was the keyword of the time, every business was holding on to the data science resources, right? They were trying to build up teams, and I think you have a valid point when when the data is not available, it's pretty useless to get folks involved with. And at that point, I remember like getting into a lot of conversations where businesses have not figured out have not identified the use cases of where they could use these guys, but they hoarded on to those guys, and it ended up a lot of frustration and back and forth and sort of getting these things going. Like it got lots of turmoil. And now we are saying the same thing with AI nowadays. Like I'm surprisingly, I find myself into more of these conversations than I would have loved to, in which they have hired, and they're trying to figure out where AI could be useful. So from your vantage point, is there any sort of qualifier metric that I should keep an eye on when I say, okay, I may need to beef up my machine learning resources or AI resources?
So maybe and correct me if I'm getting your question wrong. Is it when do you know it's time to invest more in your ML resources?
Yes.
It's a good question. Certainly, having the data, there is big data used to get a lot of play. The ability for a startup to work with small data, and usually most startups have that cold start problem, is probably equally valuable of a skill set, and maybe makes it even more difficult, right? There are all these famous charts. You can invest in data, or you can invest in data scientists, because actually you need the data scientists to make better use of the smaller data. I think that there's another train of thought here, which is you mentioned how do you know when it's the right time to monetize, and what are the right use cases to monetize, and that's a really important skill, a really valuable skill. There's a lot of fresh data scientists out there. Every university in the world has now come up with a master's program, and we're seeing the surge of rich, fresh talent without maybe as much experience out there. Times were that if anybody who even wrote data scientists on their LinkedIn profile was a high commodity because it was so rare. Now, what's really rare is someone with the experience to know not just the art of the possible for machine learning. I think a fresh graduate who's been well trained, and there are a lot of really brilliant people coming out right now that have that understand the possible, but understanding where the use cases are, what is a good scalable solution for machine learning, and what's not a scalable solution for machine learning is really important. And that's where picking the right leadership for your data science team becomes critical. There are several examples that we can talk about with this. I think maybe the FakerFact project that we did starting in my lab last year might be a good example of how just with a slight tweak of understanding what it is you're trying to solve, you can go from completely intractable problems to fully to problem that is really perfectly designed for the kind of machine learning technology that we have today.
Interesting. I think so. The other side of this is any sort of anyone who's listening to this podcast and who wants to who is considering joining a company, or at least identifying a company that's right fit for their AI ventures. So what are some of the qualifiers that you as a candidate would think of when you evaluate a company or a job role, that hey, this is a very progressive, it could sort of give me that leeway to learn and sort of create this. It's a very futuristic. So what are some of the things that you had considered in your consideration for job roles, if at all?
So what should somebody consider when they're vetting the company or the potential opportunities?
Yeah.
Certainly the leader of the data science organization is going to be critical, because that's going to be the person who's helping to drive and shape what you work on. And if that person has the experience and the knowledge for how to find a problem that and orient a problem towards something that's tractable versus something that's not tractable for data science, that's going to make all the difference between whether or not you end up doing fulfilling work or you end up maybe supplementing for engineers that are needed all over the place also. Certainly there are different kinds of companies. Some of them are dyed in the wool, born in data, and some are more more fringe, right? There's always a slew of different data and machine learning projects you can do for different kinds of companies. If you have customers, you automatically have the laundry list of customer retention, churn modeling, looking at recommendations, looking at how to bring on new customers, marketing, all of those things kind of naturally happen for no matter what you're selling, whether it's toothbrushes or software. For B2B, there's a whole other set of things that naturally have to happen. I think it's fair to say that most companies can use machine learning when done appropriately. The biggest challenge is finding the right team to execute on that.
Interesting. And I think so. You talked about faker facts. So what exactly is that? If you can walk us through that.
Sure. Yeah. So faker fact. That's a faker with an ER. Fact is the so this is a project that we started thinking about about a year ago, where fake news has been this big problem. Many of the major players are really struggling with how to solve this problem. And one of the things that kind of jumped out to me when we first started thinking about this was a lot of the discussion centered around how do you detect what's true and what's not true? How do you detect when an article is doing something is saying something that's false, or saying that's true? And that's a really difficult problem to solve when you're with algorithms. It's a very difficult problem to solve in general, but it takes a lot of. That's what real journalists are for: is for going out, getting all that data that you need in order to make a case that this is true, this is false, and then sharing that information with the right people, with the audience, so that they can make up their mind that, hey, this sounds true, this sounds false, and being able to have the evidence for that conclusion is the role of journalists and the role of fact checkers. But that's really not scalable. Fact checking is not a scalable algorithmic process. However, and I mentioned earlier, there's this subtlety of having a problem that is tractable and solvable with machine learning, and having one that's not. While truth detection may not, at least start, be a tractable problem, there are things that are very tractable to solve in this problem. And one of them is, when you think about what would fake news, why would somebody write fake news? Why would somebody propagate that kind of misinformation? And usually it's because there's an agenda. They're trying to get a goal, and that goal is whatever it is, not identical to sharing information, increasing knowledge of the world with their audience. Maybe it's to sell something. Maybe it's to motivate a certain action. Maybe it's to create a base or a following of some sort. But each of these different kinds of motivations. Maybe it's just to make you laugh, like The Onion, right? Technically, satire is also fake. And so each of these different kinds of, quote, fake news, each of these different kinds of motivations, while knowing exactly what facts are true or what facts are not true in the writing might be very difficult. What's not as difficult is detecting what kind of writing style they're using, what kind of turns of phrases, what kind of aggregate patterns you tend to see in the article. So now, if you with and this is by no means trivial, but it is something that we can conquer with modern natural language understanding and deep learning algorithms that are out there. And you can talk about some of them in a moment. You can build up the kind of algorithm so that your AI, so to speak, will read through the article, look at the words on the page, see and detect when those patterns are there, and then be able to come up with a classification. This sounds like journalism. This sounds like satire. This sounds like manipulation. This sounds like an opinion piece rather than a fact-based piece. This sounds like a Wikipedia article. And so what we ended up doing was just sort of validating this hypothesis that I had, that you can build that. And we spent several months scraping data, examples of all the these different paradigms for how you could be journalistic, how you could be Wikipedia, how you could be manipulative, and then building classifiers to detect that. And that's what fakerfact.org really grew out of that, with that idea. First, it was a research project, and then comes the next really big hurdle, which is how do you turn an algorithm that you might be able to publish on into something that the world can use. And so the website is sort of, and then there's a Chrome app, there's a Mozilla app. It's really a manifestation of how you can make that transformation from something that's just a technology to something that is a product.
Interesting. So exciting. So when you think about, say, let's solve the fake news problem. So
Mhm.
let's take the life cycle of that project, right? From very inception of, hey, it's a problem, let's solve it. If you can walk us through the designing process and sort of at the stages that it sort of incepted on, that will be really amazing.
Yeah. So we kind of left off with idea. Now we have to think about, well, how do you turn this into in order to create a product or a tool for the public to use? How do you know how to get started? Right? There are literally an infinite way of a span of different things you can do with machine learning in order to solve this problem. Starting small is always good, and even though there are all these fantastic and beautiful and easy to use now deep learning algorithms out there, we did not start with that. We started with validating the hypothesis that there even is this signal there. We started with some of the simplest algorithms that we could think of, implemented those, saw if we got signal, tweaked it, and went through this really very scientific process of, it looks like we're getting these results. It looks like we're getting, more false positives, more false negatives. It looks like we're missing this signal. We're capturing that signal, and then slowly but surely incrementing the sophistication of the algorithm until you get to the results you want. What are some of the things we did? Well, there are all sorts of ways you can embed text. One of the ways is you can just take individual words and take like the average of those words by embedding them and look for, this is a naive document tester. So using now pretty popular and pretty well-known algorithm of word2vec. This is a way of embedding individual words in a vector space so the algorithm can actually understand the mathematical representation of your words. So you could do things, and this is something that we did, 5-6 years ago when the algorithms first came out. Just take the average of all the words on the page, and that's pretty good. It captures some of the response, because now you have a vector that represents the average direction that all the different words are pointing in, and you can actually run that through a classifier, and the classifier that makes a decision: journalism, not journalism. The problem is that averaging is commutative, so word order doesn't matter, context doesn't matter as much. So then we might try different document embedding or document embedding ones that look for how do you mathematically represent the entire document as an extra context vector. From there, we moved on to really more modern techniques, using long short-term memory algorithms in order to read each word individually and come up with an embedding for the entire sentence. Using different loops in order to start doing that, from taking sentences and moving them into paragraphs, taking paragraphs and turning them into an entire article, using attention mechanisms and the whole host of different language modeling and all the different NLU techniques that we have that we have the benefit of using today in 2018. What was important about that is that we did not build the most sophisticated, most degrees of freedom, most complex things first. We had to learn what kind of signal can each of these techniques get, at which point in the model can they get them, how do you manage the compression and the re-representation of the information from the words on the page so that the algorithm can catch the grooves in the data in the best way possible, and then turn that into something that actually gets good signal.
Interesting. And so how did you end up? What are the accuracies that you ended up achieving after sort of this site is in progress?
So the accuracies are remarkably encouraging. Journalism is in the mid to high 90s in most cases, most data sets, and like I said, we do hypotheses all the time. At any point in time, somebody on the research team is trying something new, puts it up there, we check it, we see, first we check the offline measures where we get like these high 90s. And there's also, and this is something else where for recommendations, for all sorts of different examples. When you're building a machine learning product, your offline metrics are important. Understanding the gap between performance offline and performance online is also important. To give an example of that, like I mentioned, recommendations. We can come up with a recommendation algorithm for what movie what movie you're going to rate most highly. Right? Famously, Netflix did that for the Netflix prize. But also famously, it wasn't as valuable as they thought, because recommendations are the sort of thing that implicitly have these response effects, right? So you make a recommendation to somebody, and then they're going to react to that recommendation. So trying to predict how many stars someone's going to give a movie is good, but trying to predict what those second and third order effects are once you've shown someone something, what happens when they respond to that, those are things that are hard to simulate, hard to do offline. One of the ways you might attack that problem is by simulating what would happen in the real world, and more for offline measures, you're getting more sophisticated ways of detecting that offline simulation in order to get to bridge the gap between offline performance and estimating what the offline performance is going to be like and online performance. It's also an investment, though. Now you're not just in the business of modeling what the data is like, but you're also modeling how the world is going to respond to what the data is like. So you kind of double your work. Live experimentation, when you can afford it, is another way of doing it.
Interesting. And I think so. We also read a lot that even journalism is moving towards AI. They use leveraging AI to write authentic fact-based news. So how do you? So if you are relying on linguistic patterns to figure out if it's written by journalistic or if it is written by an AI bot, will that make a life of an fact checker a lot harder? If that's an AI, because AI is writing it and then they're just mirroring each other out.
So maybe you can correct my interpretation of your question. And so I'm gonna. Sometimes people respond to it and say, "Well, won't people just learn how to slip one past the goalie, so to speak?" So we named the Baker Fact AI Waltz after Walter Cronkite, and so maybe Waltz, we can trick Waltz. Maybe that's actually it's like SEO hacking for Google. And in the old days, you would do all sorts of things to your website to trick the algorithm to put you higher. What if all the fake news people out there, all the fake news authors, just try to use Waltz for evil? They try to use it as a mechanism for figuring out if they can if they can be slipped by undetected as real news, even though they're fake facts, right? They're alternative facts. And my response there is that actually that would be the dream. That's the goal. If that's one thing that putting a website like this out, or a Google app, a Chrome app out into the public does, that would be fantastic. And the reason for that is this: we're all human, at least so far, right? Not counting Walt. And because we're all human, we evolved in a certain way that really made a lot of sense when we were cave people. When we were evolving, we actually learned, it ended up being an adaptation to not always overthink things. In particular, when there's danger around, or when there's something that makes us angry, or makes us threatened, or makes us scared. We end up, it's actually better for us to not overthink it, to turn off our brains and to just respond. Often that response is running away or becoming belligerent back. Now, well, this was a great advantage when it came to figuring out how to handle tigers in the jungle, or how to respond to snakes in the forest. Maybe it's a snake, maybe it's not. Better to err on the side of caution. It ends up being exactly the sort of thing that manipulative fake news can take advantage of. And because it could take advantage of that, it can actually, there are part of these techniques that these patterns that the fake news that walls can detect is when that's starting to be triggered. And so your question was, well, what if somebody slips one by the goalie by removing these very techniques? Well, then we've done a remarkable thing, because we forced fake news propagators to take out the things that are manipulating us into not thinking about what we read. And if what we've done is created a way for people to know, to think about the facts, cognitively, to reason about what they're reading, whether it's true facts or whether it's maybe not true information, and then come to their own decision about the truth. That's a beautiful result, isn't it?
Yeah, I think that makes sense. So that's remarkable. So I think what you're suggesting is, if you need to get to an AI project, first do the research, get all the data in place, and then I think use very simplistic model to just see if it's fruiting your results, and then sort of keep iterating to see it in fruition. Is it correct interpretation?
That's right. Yeah, and I answered earlier that there's this this having the nerve to push it all the way through until you get the monetization result you want. Believe me, there's a lot of hypotheses that we've tried that actually didn't improve the model, that made it go down, not up. And when you see that happens, as long as you've approached it from a well-calibrated, well-managed expectations way, where you say, we're going to try this, we're going to learn from if it doesn't work or if it does work. And for every different hypothesis you take, you really take maximum advantage of whether it works well or whether it doesn't. And you have the leadership, whether it's in a business context, it would be senior leadership executives, maybe they're machine learning experts, maybe they're not. Or is it just a research project that you're doing on your own because you're getting ready to enter the workforce? Making sure that everything you try has a well-scoped value, whether it improves the score or whether it doesn't improve the score, you understand what you did underneath and you can learn from that result, is one of the ways you can get around this hump of, oh, well, we didn't prove value. Because no matter what you did, you learned from what you built. And so this is really an agile data science methodology. The original concept of agile development was not create an MVP and get it out there, or first thing that can make you money. It was, what's the minimum thing that you can do in order to learn if it makes the product better or worse? And put that out there.
Interesting. And if I'm a business and I'm trying to look for a good leader in my organizations to lead my data science initiatives, what are some of the things you could suggest me that I could look for in the talent?
Well, I would look for somebody who likes to build. There are all sorts of soft skills, there are all sorts of management skills and important techniques for a leader to have that have nothing to do with machine learning, that are sort of universal across all good managers and all good leaders. In particular, and this is true in many technical management cases, having somebody who understands what the team is building, who can set the direction, who can also know that subtle distinction between what's a tractable ML problem and what's an intractable ML problem, like the example we talked about a little while ago. You really need the technical chops in order to be able to do that. Now, that's not the only thing, but that's an important thing. And also having the technical chops so that you can guide a team to being able to break down the different hypotheses that they're going to test, the different tweaks to an algorithm that might make it better, might make it worse. And also, importantly, know when to stop. When have you met the right level of accuracy, the right level of performance that the business needs, so that you're not investing all of your time chasing smaller and smaller return for more and more effort.
Interesting. And if suppose you end up joining a company and you are given this task to put together a rockstar data science team, what are some of the first few considerations that you would do, or what are some of the steps or you would take to get started on that journey?
Well, understanding the business is probably the first thing that that you need to do whenever you join the company. There's another cliche of doing fancy technology things for its own sake, because that's what you're good at. So we'll just find a nail for our hammer, so to speak, right? That can often have bad results, and this cliche of people investing in data scientists or machine learning engineering talent that's very expensive and not getting a return can be the consequence, can be the result of maybe not having a good understanding of what the business goals are, and then working from that to figuring out what needs solutions, and then specifically what can be solved with these machine learning solutions, or with statistical solutions, or leveraging the data solutions. So understanding the business is, of course, the most important thing. Depending on where you're coming in the maturity of the team, understanding the different skills that your team members have is really important. So getting to know the members of your team, getting to know what they're good at, what they're not good at, what they enjoy doing, what they don't enjoy doing, and then writing out a roadmap for how you fill in the gap and make sure that you have a fully well-rounded team is going to be really important too.
Interesting. And from your experience, like, what are some of the challenges that you have faced putting together a data science team in a startup or whether in a company?
Yeah, hiring quickly is hard for everybody. It doesn't matter what company you're at or who you are. It's hard to find the right talent. It was hard historically to find any talent at all. And it's still hard to find people with the right kind of experience and the right kind of intuition or second nature that they've developed through practice for what the sorts of understanding that I just described. There's no replacement for practice. And while some people it might come more quickly than others, a lot of the very abstract and not specific examples that I've just been giving about understanding the difference between a tractable problem and a non-tractable problem, understanding how to frame hypotheses so that you learn no matter what when you make a change to your algorithm, understanding, we haven't talked at all yet about how you bring an algorithm that works on your laptop to something that works on, or maybe in a cloud cluster that you've created, to something that works as a product in serving environments. Those are all different things that if you haven't had the practice and most people have not had the practice, almost certainly have not had the practice, sufficient practice coming out of the gate, you need to develop that skills. And there's no replacement. There's no replacement for time spent on that.
Interesting. I think so. One thing that I get sort of surprised a lot by, like, almost every company is flooded with IT professionals. So they have, like, most of these companies have been hiring with a lot of these IT folks. I remember one of the Fortune 20 company I was recently in conversation with, and they said, "Hey, Vishal, I'm looking for an interesting, I think, computer vision engineer." I said, "Okay." Mm-hmm. And he said, "Hey," and he said, "Have you tried looking inside the organization?" He said, "No, my folks are pretty primarily IT folks." So, and they have been looking for that guy for at least now a couple of probably 2 years now. They have interviewed few and not getting whoever they want to hire. So I think one thing that we are seeing is that almost every company is filled with a lot of people, but they don't retrain them fast enough to get to this new, because if you see from IT to data to AI, it's not a very far jump. So what is your thought around this idea of retooling the workforce to get to the talent that you would probably need in the future?
Yeah. So this is something that I thought about quite a bit. You mentioned that I spent several years building out the Galvanize program for training. And this was in the days that galvanizeU was one of the first master's programs out there, and so we came up with shorter term solutions like immersive programs or corporate training programs that were really focused on not giving you all the tools that you need in order to be a full-fledged data scientist ready to handle any task, but giving specific skills, allowing people that had one set of skills and enabling them to transfer those over to other contexts. That's really valuable. There are some things that there's no replacement for. I would say, if you're an engineer and you are a good engineer, you know how to build the right level of abstraction. You know how to build in the right sort of modules and testing into your code. That's going to get you a long way. And my recommendation would be to focus on training opportunities that really give you an understanding, not just of how to call different libraries and blindly execute, but how to really understand the math behind what's going on, how to understand the information theoretic underpinning of what your algorithm is doing and why it's doing that, the representation in different vector spaces as you go from information in its raw form, like text, to well compressed vectorized form, like the example I gave with fake news detection. Getting those skills are not nice to have. They're essential, because otherwise what's going to happen is you're going to call some libraries. You're going to hit a bump in the road, maybe not the first time, but eventually, inevitably, and more often than not, the first time. And you're not going to know how to fix it. You're not going to be able to actually solve the problem. Or you might solve the problem, but you're going to be solving the problem by randomly trying things. And now you're not making forward progress every time you make a change to your algorithm, every time you develop a hypothesis. You only win one way, when it goes up, and you lose all the other times. And there are more ways to go wrong than there are to go right, which means in general, you're going to make less progress. Most of the time, you're not going to do any progress. On the flip side, if you have a very strong, say, mathematical literacy, a background in physics or other sciences, but you don't have that background in as a developer, then there's a whole other set of tools and of techniques that you should learn. And these center around the sorts of things that I mentioned before. How do you build reproducible code? How do you make sure that you're testing everything? Because at some point, no matter who you are, someone else is going to be touching your code, someone else is going to be breaking your code, and that someone else could be you 1 month later when you forgot what you did a few months ago. And so you need to build in these mechanisms, these best practices, so that you're not rewriting the same code over and over again each time. You're not building something that is super fragile, so that way when you want to make a change, which inevitably is going to happen, you end up breaking everything and spending all of your time in debug mode.
Interesting. That's a very interesting thought. So if we talk about some of your best hires that you have done in your profession, like what are some of the ingredients of your best hires that you could share?
The ingredients of sorry, I didn't catch the word.
Your best hires. So anyone that you hired, what are some of the things that you look for?
Well, I actually look for spikes in both of those different poles. I definitely look for people that have that deep mathematical literacy, are very well adept at understanding what it is they are building. But even if maybe they don't have as much training in how to develop good code. If you have a team that's nothing but that profile, you're going to fail. At the same time, if you have a data science team that's nothing but engineers who know how to call libraries but don't really know how to improve on their product once they call that first library, whether it works or doesn't, it's kind of like a coin flip. You're going to fail too. So, going back to where I said before, having a well-rounded, holistic team is always the best solution.
Interesting. And let's talk about sandbox. That suppose you are working as a data science leader and you were asked to put together an AI lab. So, what are some of the things that you could share that whoever is given this task should consider?
Building an AI lab or an industry lab, so to speak. Well, I think the first question that I would have is what kind of time horizon you have for this lab, the funding and when the expectation of return is going to be, because that's going to really characterize the nature of the projects that you try, right? A lab that is purely for research and purely for just figuring out new technologies that may or may not, the mandate is not to turn it into a product, but to see if you come up with the next greatest thing. While those tend to move more slowly for obvious reasons, that's going to be a very different kind of lab than one that, while an R&D auspices, is still going to be expected to return value to the business in a shorter time frame. And so understanding what the context is there is where my mind goes first. Right? Resources. So an important thing if you have a lab is understanding not just the funding for hiring researchers, but also what kind of compute resources do you have. If you've got a limited amount, if people can only work on their laptop, researchers can only work on their laptops, that's going to be a very different kind of game than having an in-house cluster that you can use, or having a certain volume of GPUs and instances in the cloud that you can use. And so that's going to really characterize the nature of what kind of projects you take on.
Interesting.
Last but not least, it's the research. Yeah. Sorry, I was just going to say the people matter too.
Interesting. No, I think that's fabulous. So now we're at the tail end of the conversation, by the way. So in this, I want to spend somewhat more time around your journey. So in your journey so far, what are some of the tenets of your success? Like if you say some of the quality or some of the things that really helped you be what you are, what would that be?
I've been really, really lucky. I think that there are plenty of people that are joining the data science or machine learning community now in the industry now that are just as qualified as I was when I joined, and there's even more, I'm sure, that are more qualified. I started at a very a rich time where these skills were not as available, and I was lucky enough to get to develop the skills and the experience that I didn't have when I joined. When that ended up making that enabled me to stay a little bit ahead of the curve, so to speak, on what the expectations were for data scientists. I think back when I first left academia and went to industry, I kind of had these thoughts, man, I guess that's what I've learned for this life. I'm done. I'm not going to have any chance to learn anything else because now I'm going to workforce, and I couldn't have been more wrong. Almost none of the actual technologies or the actual techniques that I was using when I left academia are things that I use today. So Python and R are still around, and I tend to use Python more, and R is really more of an academic tool. The math has not changed. Obviously, the math is similar, and having that firm foundation in mathematical literacy and in development practices, that's fairly timeless. But the specific techniques, using deep learning, using algorithms that are pretty much the staple in industry that are not deep learning, things that you find in Spark ML or in like XGBoost, none of that existed when I joined, and so none of the techniques that I mentioned that we used for Faker Fact were none of the natural language processing was almost 100% a different kind of project, when I joined. And so the fact that I'm constantly reading journals, reading new technology, and not even because it's something that I think that I need to do or that I spend time so I could keep up. It happened naturally as part of doing the job. You just have to keep up with these with these new techniques and develop a very rich opportunity to learn every single month.
Beautiful. And what are some of the favorite reads or some of the favorite books that you have read that you would like to share with our listeners and viewers?
Yeah. Earlier I mentioned for education purposes, the one I always recommend is the deep learning book, the Benjo book that came out. It's free online. It has, even though it's a book about deep learning, the first third is really about getting those fundamentals down. And so if you're just starting with statistics, probability, linear algebra, fundamentals of machine learning, it's a great end-to-end summary of exactly what you need. And now you're all ready to start reading about deep learning once you master those pieces. Fiction, I like to read all sorts of fiction. I still like Star Wars. Stories sometimes are fun. There's a book that came out several years back now. Kevin Kelly, so he's one of the Wired founders, called What Technology Wants, which I think about often still nowadays. And the thesis there that Kevin Kelly talks about is that there's this phenomenon where different technologies get invented by different people in different places who never had the chance to communicate. And there's all sorts of examples of this. He uses the example of Edison and the light bulb being one of the last people to invent the light bulb. There's examples. I used to wonder about, when I was young, I said, well, Robin Hood had the bow and arrow, but didn't the Native Americans have bows and arrows too? And didn't they have them before? Who invented the bow and arrow? It turns out the answer is both, right? The spoon and more sophisticated technologies, of course, that's happening too. And nowadays, with the internet, it's a combination of both. People can come up with the same idea all over the place. Now, what does Kevin Kelly say about this? He says it's a lot like evolution. In evolution, the environment determines what kind of adaptations the organisms end up evolving to develop. And for technology, it's kind of like that. I don't necessarily think that you would say that it's because of survival of the fittest type thing, although maybe a little bit. But there is this, at least, plausible thesis that once humanity has mastered electricity, and once humanity has mastered working with glass and the sorts of metals that go into making a light bulb, the invention of a light bulb is inevitable. And
interesting.
People are going to create that. As long as you have enough inventors out there, several of them are going to create that invention. And this is something that we've seen throughout history. Calculus was invented by two different people. And we see this often with algorithms today that I read about. Sometimes I'll read in recommendations and in search relevance, the same people came up with almost the same algorithm in two different contexts and may or may not have actually been influenced by each other.
That's pretty cool. So, last but not the least, so if you want our listeners and viewers to take away something from this conversation, so what would that be? So, what would be your closing remark to our listeners and viewers?
That's tough to say what the best final words are going to be. I suppose I want to punctuate that the importance of this theme that I was pushing, that when you're doing this development, you always want to learn every time. Having this style data science approach to building is incredibly valuable and something that really makes the difference between a successful team and an unsuccessful one.
Beautiful. So with that, thank you so much, Mike, for your spending your time with us and sharing your thoughts and your sort of ideas on how some of the leaders should think about putting together an AI team and what are some of the good practices there. You're always welcome back on the podcast, and wish you nothing but success, and thank you for spending time with us.
Thank you, Sean.
Yeah, thanks.
Yeah. I thought I was sick of home, but actually I was homesick. Never really knew that I would have to grow up so quick. I'm so uncomfortable, don't know anybody here. Just a couple dudes that I met once, that's it. And I go into the booth feeling nervous. Got butterflies in my stomach like I'm so worthless. Is the mic on? I don't know how to work this. Inside I'm breaking down, I hope I'm not up on the surface.